Russia spent decades building what many analysts once described as one of the most intimidating air defense networks on Earth. Long-range surface-to-air missiles, expansive radar coverage, layered defensive zones designed to deny NATO aircraft access long before they could reach Russian airspace. This architecture was shaped by Cold War thinking, refined through post-Soviet modernization, and showcased regularly in military parades and state media. On paper, it looked formidable, and in many respects, it still is. But the true test of a military system is not how it performs in doctrine or simulation. It is how it performs under sustained pressure in real war. And the pressure test Russia is facing today did not arrive in the form Moscow expected. It did not come from stealth bombers or cruise missile barrages. It did not come from NATO air power probing Russian airspace. Instead, it arrived quietly, cheaply, and in large numbers. It came in the form of drones, small, expendable, unmanned aircraft, many built with commercial components, many costing a fraction of traditional weapon systems, and many designed to be lost. Over the last 2 years in Ukraine, these drones have transformed from a secondary tool into one of the central instruments of modern warfare. According to assessments from the Ukrainian Air Force and analysis by organizations such as the Institute for the Study of War and the Royal United Services Institute in London, Russia has increasingly relied on one-way attack drones, loitering munitions, and mass-produced FPV systems to supplement its conventional strike capabilities. Individually, these drones are rarely impressive. Most are slow, many are loud, some are crudely assembled, but their effectiveness does not come from sophistication. It comes from scale. They arrive in waves, sometimes dozens in a single night. They approach from multiple directions, at different altitudes, often deliberately staggered to complicate detection and tracking. Some are decoys, some carry real warheads, some are paired with cruise missiles or ballistic strikes to stretch defensive systems even further. The goal is not precision in the traditional sense. The goal is pressure. Even when most of these drones are intercepted, a small percentage getting through can still damage infrastructure, disrupt logistics, or force defenders to make costly decisions. And that is where the deeper issue begins to emerge. Modern surface-to-air missile systems were designed to defeat high-value threats: fighter aircraft, cruise missiles, ballistic missiles, fast, complex targets that justify the use of expensive interceptors and advanced sensors. These systems excel when facing a limited number of high-performance threats. Drones break that logic. Many drones fly low and slow. Many have small radar signatures. Some are built with composite materials that reduce detectability. Others follow terrain or civilian flight paths. And most are cheap enough that losing them has little impact on the attacker's broader strategy. This creates an uncomfortable imbalance. Defending against a low-cost drone with a high-cost missile can work tactically. The target is destroyed. The immediate threat is neutralized. But over time, this approach creates economic strain. Western defense analysts at Rand and Rusi have repeatedly highlighted this dynamic in public reports. If the cost of defense consistently exceeds the cost of attack, the attacker gains a long-term advantage even if most attacks fail. Ukraine experienced this reality early in the war. Its air defenses proved effective, but sustaining them against nightly drone attacks required constant resupply of expensive interceptors. Over time, the focus shifted toward finding ways to neutralize drones more cheaply and more sustainably. Then NATO started paying closer attention. In 2024 and into 2025, several incidents forced NATO countries to confront a reality they had hoped would remain theoretical. Russian origin drones violated or drifted into NATO airspace over countries such as Poland and Romania. Some were intercepted, some crashed, some forced temporary disruptions to civilian airspace and airport operations. These incidents were confirmed by national defense ministries and reported by outlets including Reuters and the Associated Press. Nothing catastrophic occurred. No escalation followed, but the signal was unmistakable. Traditional air defense responses were being triggered by threats that were slow, cheap, and often unintended. Scrambling fighter jets or preparing high-end missile interceptors for every drone incident is not a sustainable posture, especially when drones are no longer rare anomalies but a routine feature of modern conflict. This is where NATO's approach began to shift in a meaningful way. Rather than treating drones as a secondary nuisance to be handled by existing air defense systems, alliance planners increasingly began treating counter-UAS as its own mission set. Not as an extension of classic air defense, but as a separate layer with its own priorities: lower cost per engagement, faster response times, higher tolerance for volume, and systems designed specifically to handle small aerial threats without exhausting high-value assets. This shift did not happen overnight, and it did not come with dramatic announcements. It emerged gradually through exercises, procurement decisions, and lessons drawn directly from the war in Ukraine. This is where the so-called drone killers enter the picture. According to defense reporting from outlets such as Defense News and Janes, NATO countries along the eastern flank, including Poland and Romania, have begun fielding mobile counter-drone systems designed to intercept unmanned aircraft using relatively low-cost means. These systems are not designed to dominate airspace in the traditional sense. They are designed to quietly and efficiently remove drones from the sky before they can create disruption. One example that has drawn attention in open-source reporting is the US-made MIROPS counter-UAS system. It is truck-mounted, mobile, and designed to operate in environments where electronic warfare and GPS disruption are expected. Instead of firing expensive missiles, it launches small interceptor drones that physically collide with and destroy hostile drones in flight. The concept is deceptively simple, but strategically significant. If drone attacks rely on economic pressure and saturation, then defenses must neutralize that pressure without creating a financial drain of their own. NATO is not trying to win the sky in one dramatic moment. It is trying to make drone defense routine, repeatable, and sustainable. And in doing so, it is quietly exposing a structural challenge in Russia's air defense posture. To understand why NATO's counter-drone shift matters so much, you have to look at how Russia's air defense system was actually designed to function. Russian air defense doctrine has always been built around centralization and hierarchy. Long-range radars detect threats far from defended areas. That information is passed upward through command nodes, filtered, analyzed, and then distributed down to missile batteries and gun systems positioned in layered rings. High-altitude threats are engaged first. Anything that slips through is handled by medium-range systems. Short-range systems protect key sites at the very end of the chain. Against traditional threats, this model makes sense. Fighter aircraft and cruise missiles are fast, expensive, and limited in number. They justify careful target prioritization and the use of high-end interceptors. In that environment, centralized control reduces the risk of mistakes and maximizes the effectiveness of each shot. Drone warfare flips those assumptions. Drones do not behave like aircraft. They do not present themselves as a small number of high-value targets. They arrive in clusters. They fly low. They blend into ground clutter. Some deliberately mimic civilian objects. Others are meant to be sacrificed simply to trigger sensors or exhaust ammunition. Analysts at the Royal United Services Institute and RAND have both emphasized a key point here. Large surface-to-air missile systems are optimized for quality threats, not quantity. They are extremely good at tracking a handful of fast objects. They are far less efficient when forced to manage dozens of slow, low-altitude targets arriving at once. This problem has been visible throughout the war in Ukraine. Ukrainian air defense officers have described nights where drones approach from multiple axes at slightly different altitudes, deliberately timed to complicate tracking. Some are real threats. Some are decoys. Some are simply designed to force radars to illuminate and reveal their positions. Reuters and the Kyiv Independent have reported on these tactics repeatedly, citing Ukrainian military briefings and interviews with air defense personnel. Russia uses similar logic in reverse. But here is the catch. This strategy only works if the defender is forced to spend more than the attacker. Once the cost equation shifts, saturation loses much of its power. That is the core insight behind NATO's new counter-drone approach. These systems are not meant to replace high-end air defenses like Patriot, NASAMS, or IRIS-T. They are meant to protect them, to absorb low-end threats so expensive interceptors can be preserved for missiles and aircraft that actually require them. In practical terms, this creates a buffer. Drones are handled by systems designed to be fired repeatedly without financial pain. Missiles are reserved for threats where they actually make sense. This may sound obvious in hindsight, but it represents a significant shift in how air defense is organized. There's another layer to this problem that often gets overlooked: human attention. Drone attacks do not just strain equipment, they strain operators. Multiple tracks, multiple directions. Little time to react. Even highly trained crews can become overloaded when dozens of targets appear simultaneously. Western defense analysts increasingly describe this as a decision bandwidth problem. Not a lack of firepower, but a lack of time and cognitive capacity. Automation changes that equation. Modern counter-drone systems rely heavily on sensor fusion and automated target assignment. Radars, electro-optical sensors, and thermal cameras feed data into software that prioritizes threats and assigns interceptors. Human operators supervise and authorize rather than manually calculating lead angles or deciding which drone matters most. Defense industry reporting from Jane's and Defense News has highlighted automation as one of the defining features of next-generation short-range air defense. The ability to handle volume without slowing down is now more important than raw range or speed. This is another area where Russia's air defense architecture faces limitations. Russian systems are capable, but they remain heavily centralized. Decisions flow upward and downward through command structures. That approach works when threats are limited and predictable. It becomes strained when the sky fills with low-cost targets arriving faster than decisions can be made. This is not a question of technical incompetence. It is a question of design philosophy. And that difference in philosophy has strategic consequences. Drone warfare was supposed to be a way to apply pressure without escalation, to test defenses, to probe responses, to impose costs while staying below thresholds that trigger direct confrontation. But if drones are intercepted quietly, cheaply, and routinely, that pressure loses much of its effect. A drone that disappears from radar without a dramatic response does not generate panic. It does not create headlines. It does not force political decisions. It simply fails. That matters more than it sounds. It reduces escalation pressure. It limits coercive signaling, and it forces the attacker to reconsider how much value drone saturation actually delivers. This shift is not confined to Ukraine. It is shaping how NATO thinks about defending its own territory. Along the eastern flank, counter-drone systems are being layered into existing air defense networks. Sensors are shared across borders. Mobile systems are redeployed as threat patterns change. Lessons learned from real incidents feed directly into procurement and training cycles. Russia's adapting as well. Moscow has expanded drone production, diversified attack profiles, and invested heavily in electronic warfare. Analysts at CSIS and RUSI have documented these adaptations in detail. But adaptation under sanctions and industrial constraints is slower than adaptation inside a large alliance with multiple defense industries. This is the deeper issue now emerging. The drone war is no longer just about who can build the most drones. It is about who can defend against them cheaply, at scale, and without exhaustion. NATO is deliberately moving in that direction, not with dramatic breakthroughs, but with practical systems designed to make cheap threats unremarkable. And that is where the long-term balance begins to shift. What NATO is doing now is not about chasing technological superiority for its own sake. It is about changing the math of modern conflict. Drone warfare only works as a pressure tool. If the defender is forced into bad choices, either allow drones through and take damage, or shoot them down using systems that cost far more than the drone itself. That dilemma has driven much of Russia's strategy over Ukraine. Even when most drones are intercepted, the defender still pays a price in ammunition, fatigue, and political pressure. NATO's counter-drone shift is designed to remove that dilemma. The new systems being fielded along NATO's eastern flank focus on economic symmetry. The idea is simple. If a drone costs a few $1,000s, the interceptor should cost roughly the same. Not hundreds of thousands, not millions. Close enough that the attacker does not gain an economic advantage through volume alone. This is why mobile counter-UAS platforms matter more than they appear at first glance. According to reporting from Defense News and Jane's, systems like MIROPS are designed specifically for environments saturated with cheap drones and heavy electronic warfare. They do not rely on expensive missiles for every engagement. Instead, they use small interceptor drones guided by sensors and increasingly autonomous software to physically destroy incoming targets. That approach does two important things at once. First, it reduces cost per engagement. Shooting down a cheap drone with another relatively cheap system removes the economic leverage behind saturation attacks. Second, it reduces escalation pressure. A drone intercepted by a small counter-UAS system does not trigger the same political or military response as launching a high-end missile or scrambling fighter jets. This distinction matters more than most people realize. Throughout 2024 and into 2025, NATO had to respond to several drone-related incidents near its borders. Russian-origin drones drifted into Polish and Romanian airspace. Some crashed, some were intercepted, some caused temporary disruptions to civilian air traffic. These incidents were confirmed by national defense ministries and reported by outlets such as Reuters and the Associated Press. Each incident posed the same question. How do you respond without escalating? High-end air defenses send a signal. Fighter jets send a signal. Missiles send a signal. Sometimes that signal is necessary. Often it is not. Low-cost counter-drone systems allow NATO to respond quietly, automatically, locally. A radar track disappears. An interceptor launches. The drone is gone. No headlines, no emergency meetings, no visible escalation. From a deterrence perspective, that silence is powerful. It denies the attacker feedback. It removes the spectacle. And it strips drone incursions of much of their political utility. This is where NATO's approach begins to diverge sharply from Russia's. Russian air defense doctrine assumes that pressure creates leverage, that forcing visible responses drains resources and creates opportunities for escalation control. But if those responses become invisible and inexpensive, the pressure loses effectiveness. Western analysts at RUSI and RAND have described this as escalation management through denial rather than punishment. Instead of threatening retaliation, NATO is simply closing off the space in which pressure tactics operate. And that creates a strategic headache for Moscow. If drone saturation no longer imposes significant costs, Russia has fewer low-risk tools available. More expensive options remain: cruise missiles, ballistic missiles, manned aircraft, but those carry far higher political and military risks. In other words, NATO's counter-drone systems compress Russia's escalation ladder. They remove the lower rungs. This shift also exposes another constraint Russia faces: industrial scalability. Russia has proven it can produce large numbers of drones, often using commercial components and simplified designs. Investigations by open-source analysts and groups like Conflict Armament Research have documented this in detail. But defending cheaply requires more than building drones. It requires producing sensors, interceptors, software, and integration at scale. NATO has an advantage here that is easy to underestimate. Once a counter-drone system is standardized, it can be produced across multiple countries. Poland, Germany, the United States, and others can all contribute components, upgrades, and training pipelines. Ammunition and interceptor production can be expanded without relying on a single factory or supply chain. Russia does not have that same redundancy. Sanctions constrain access to components. Production is more centralized. Replacing losses takes time. NATO's approach, by contrast, is designed to improve through use. Every interception generates data. Every exercise refines software. Every deployment feeds back into procurement. This creates a learning advantage. Drone warfare evolves quickly. The side that adapts faster, not the side with the biggest stockpile, gains the edge. NATO's counter-drone posture is built around rapid iteration rather than fixed solutions. This is why these systems are appearing quietly without major announcements. They are not meant to be symbols. They are meant to work. And when they work, they change behavior. Drone incursions become less frequent. Probing flights become less useful. Pressure campaigns lose their return on investment. The attacker must either escalate or disengage. Neither option is attractive. This is the strategic consequence Russia now has to contend with. Russia isn't standing still either, and that's the point. Open source tracking and analysis from groups like RUSI and CSI show Russia constantly adjusting its drone playbook. More launches, simpler builds, mixed waves, decoys, and electronic warfare meant to blur sensors and slow responses. It sometimes works until defenders adapt again. But that adaptation cycle has a ceiling. Every tweak costs production capacity, training time, and reliable components. And under sanctions and industrial strain, it gets harder to scale fast. NATO's counter-drone push is built around the opposite advantage. Multiple countries testing in parallel, then spreading whatever proves effective across the whole network. So the big shift isn't that drones are going away, it's that the shock value fades once defenses can swat them down cheaply and routinely. And when the pressure tool stops creating expensive headline-making reactions, it stops generating leverage. That's why these drone killers matter. They don't just hit drones, they hit the economics and the escalation logic behind them.